And so we come back to complex numbers. As I said, complex numbers arose out of the search for the general solution of a cubic equation. Why did they find why were they just trying to find the general solution of a cubic equation? Not that they needed it, they didn't need it for survival. Well, that's what mathematics is all about. You try to find general solutions to problems which don't seem to have any use. That's what pure mathematics is all about. This is a question from pure mathematics of how ax cubed plus bx squared plus cx plus d is equal to 0 is solved in a general way. We didn't realize that it gives us complex numbers, and complex numbers will one day help us understand one of the most fundamental properties of the universe. But then that is how the universe works, and that is why they give a lot of funding to pure mathematics also, although it seems that these people, the people who work on pure mathematics, are doing useless work. But it is not useless. We never know how useful somebody's work might be, which seems useless today. Coming back to complex numbers, the square root of a negative real number is called an imaginary number. For example, the square root of -4 is, you can write it as 4 times -1, and so the square root of that is square root of 4 times square root of -1. Square root of 4 is 2, and square root of -1 is I. Again, square root of -16 by 9 is 16 by 9 times -1 square root. So the square root of 16 by 9 is 4 by 3, and the square root of -1 is I. So therefore I is equal to the square root of -1. Okay, so this is what iota is all about. Iota is the square root of -1. And from this definition of iota as square root of -1, all other natural numbers can be defined, because every number can be defined as, every negative number, say every square root of every negative number can be defined as the positive version of that number multiplied by -1. And so all that you have to deal with is separate out the positive part of that number and separate out the -1. Both will be under square root, and so therefore if I am to express square root of -169, I just write it as 13 times iota, because square root of -1 is defined as iota, and square root of 169 is 13, so 13 times iota is what square root of -169 is. And so this is how it works. Okay, so if iota is square root of -1, then what's iota square? Iota square works in the same way. So most of these complex numbers, even though they are defined like that, but then they follow the rules of ordinary mathematics. So I square can be written as I times I, and so that's square root of -1 times square root of -1, which is equal to square root of -1 squared, which gives us -1 as the answer. Similarly, I cube is equal to I square times I, so that's equal to -1 times I, so that's equal to -I. I to the power of 4 is equal to I cube times I. What is I cube? Again, we just saw that it's equal to -I. So -I times +I, so that's -I squared, and I squared itself -1, so it's minus of -I, so that's +I, right? Sorry, +1. So I to the 4 is -1 the whole square, so it's equal to +1. And so I to the 4th power, I to every 4th power is equal to +1. So I to the 4 is 1, I to the 8 is 1, I to the 12 is 1, I to the 16 is 1, and so on. Similarly, I to the 4n plus 1 is equal to I to the 4n times I. So that's equal to +I. I to the 4n plus 2 equals I to the 4n times I square. So that's equal to I square, because I to the 4n is again equal to 1. And I to the 4n plus 3 again reduces to I cube, and I cube is -I. So now you'll ask me, how do I play around with I so that I can find the value of any expression containing different powers of I? For example, if I to the power of 19 is added to 1 by I raised to the power of 25, and the whole thing is raised to 2, that is squared, what's that value equal to? So it could be 4 or -4 or plus I or minus I. Okay, so what's given? I to the power of 19. I'll write I to the power of 19 as I to the power of 20 minus 1, because 19 is 20 minus 1. So that's I to the power of 20 times I to the power of -1. So imaginary numbers, the number iota, for example, follows all the usual rules of mathematics, which means it follows the rules of exponents as well. So therefore, I to the 19 can be written as I to the 20 times I to the -1. I to the 20 is, as we know, equal to +1 times I minus 1. That's 1 upon I. Multiply by I upon I. So this gives you I divided by I square. So that's equal to I divided by -1. It's equal to minus I. And so we get option D as the answer.